Imagine building a skyscraper. You wouldn't just start piling bricks, would you? You'd need a plan, a blueprint. Software engineering is no different. Before a single line of code is written, we need a blueprint. This is where software modeling comes in. It's the process of creating a simplified representation of a software system. This helps us understand the system's structure, behavior, and interactions. Just like a blueprint guides the construction of a building, software models guide the development of robust and reliable software. Software modeling helps us visualize complex systems, making them easier to understand and manage. It allows us to identify potential problems early on, reducing costly rework later in the development cycle. By using models, we can communicate our ideas effectively with stakeholders, ensuring everyone is on the same page. In essence, software modeling is an essential practice for successful software development, laying the foundation for efficient, high-quality software solutions. Flow-oriented modeling is a specific type of software modeling. It focuses on how data moves through a system. Imagine a river, its currents winding and changing direction. Flow-oriented modeling maps out these currents of data. It shows us where data comes from, how it's transformed, and where it goes next. This approach is particularly useful for systems where data transformation is central to their function. Think of a banking application. Data about transactions flows through the system, being validated, processed, and stored at various stages. Flow-oriented modeling allows us to visualize this journey, making it easier to design, implement, and maintain such data-intensive systems. By understanding the flow of data, we can identify bottlenecks, optimize processes, and ensure data integrity throughout the system. At the heart of flow-oriented modeling are data flow diagrams, or DFDs. These diagrams visually represent the flow of data within a system. They use a simple set of symbols. Squares represent external entities, circles represent processes, arrows represent data flows, and open rectangles represent data stores. Each process in a DFD represents a transformation of data. This transformation needs to be clearly defined, which is where process specifications come in. These specifications describe the logic behind each process, detailing exactly how the input data is transformed into the output data. Finally, we have the data dictionary. Think of this as the glossary of our data universe. It defines all the data elements used in our system, ensuring everyone understands the meaning and format of each piece of data. Together, DFDs, process specifications, and the data dictionary provide a comprehensive blueprint of the system's data flow. Section 4. The power of flow. Benefits of flow-oriented modeling. The beauty of flow-oriented modeling lies in its simplicity and clarity. It provides a visual representation of complex systems, making them accessible to both technical and non-technical stakeholders. This shared understanding facilitates effective communication and collaboration throughout the development process. By breaking down a system into its data flow components, we can identify potential issues early on, such as data redundancies, inefficient processes, or potential security vulnerabilities. Furthermore, flow-oriented modeling promotes modular design. By decomposing a system into smaller, manageable processes, we can develop and test each module independently, leading to more robust and maintainable software. In a world increasingly reliant on data, understanding and managing data flow is paramount. Flow-oriented modeling provides the tools and techniques to do just that, making it an invaluable asset in modern software engineering. Section 5. Flow in action, real-world examples. The applications of flow-oriented modeling are vast and varied. Let's take the example of an e-commerce website. The flow of data starts with the customer browsing products. This data is then used to recommend products and personalize the shopping experience. When the customer makes a purchase, payment information is processed, inventory is updated, and shipping details are generated. Flow-oriented modeling helps us visualize and manage this complex web of data interactions, ensuring a seamless and secure online shopping experience for the customer. From financial systems to healthcare applications, from manufacturing processes to logistics and supply chain management, any domain that involves the transformation and movement of data can benefit from the insights provided by flow-oriented modeling.